Hi Marco, I'm going to start by opening the file I just sent you by email. And you find the model fitting right in the first spreadsheet of the workbook, the calculations in the second, including the description of the model and which parameters are being calculated and how. Okay, the first thing you need to make sure is that your Excel version has the solver add-in installed. So you go to here, Excel options, I forgot where this is, add-ins, there it is. Now here, Excel add-ins. So the solver is a tool that will solve problems given a number of constraints. And most likely you won't have solver add-in activated. You just have to click on it, click OK, and Excel will activate it. It comes with all distributions of Excel. Now here I just have some data. This is probably what you remember now in the log space. So if you change one of these values, say 2 for instance, you see the fitting is not perfect now, and we have here the parameters of the model, and they are taken from here, so you can have a look what this means exactly. They'll be used in these calculations. And now you look for data, look here in the analysis, and you have solver on. So until you activate the solver, you won't see it here. Now let's open solver, and what solver is saying is that there is a target cell which is already preset. So this target cell is the sum of the differences between what you see and what the model predicts. So this is the target, and you want the sum of these differences to be as small as possible, meaning that the model fits the data as well as possible by changing cells G2 to G6, G2 to G6, which are used on the other spreadsheet to calculate the shape of this line. So here you're producing the results of predictions made in the second spreadsheet. This is not very important when you're using the tool. You just have to put your data here and then come to solver and run it. Now you can choose a number of things that should happen to the value of this cell. You want it to be as small as possible. So there it is. So I want this cell to be as small as possible by changing these cells. Here we go. And notice the values here. And the values of the solutions are going to change slightly. There you are. And now you see that the line itself changed as well. Now you could choose to keep the solver solution, the new solution, and you have the new values. These values describe this behavior, this dynamic behavior. Now let's say you want to go back to the other solution. So I just put 0 here. And you can go back in this screencast and find out what the previous values were. And if this tool works well, you'll find out, of course, by changing this, you saw that the differences changed a little bit here. And of course, the sum changed as well. So let's do it, solver. And let's find out if we get the previous values by rerunning the tool once we reset the value of this observation to the previous value. Here we go, solve. And there you are. Now you can go back in the movie and compare these values with the values you had before as the optimal solution. Let me know if you need any help. We can set a GoToMeeting session or any other way you prefer and go over a fit to experimental data you have obtained. Bye now.